Hi, my name is Courtney Miller. I'm a first-year software engineering PhD student at Carnegie Mellon. This is my colleague Chanel, and today we're going to be talking with you about our paper, Did You Miss My Comment or What? Understanding Toxicity in Open Source Discussions. Now, before we get into the nitty-gritty of the research methods, we want to make sure we're all emotionally invested in the narrative, so we're going to go ahead and start with some motivation. First, the definition of toxicity, which we define as rude, disrespectful, or unreasonable comments that are likely to make someone leave a discussion. This definition came from Google's Perspective API, which is an online tool for detecting certain kinds of toxicity, and this definition is in alignment with commonly used definitions of toxicity in toxicity research. Now, online toxicity is pervasive across the internet. According to the Pew Research Center, for example, 4 in 10 Americans have experienced online toxicity themselves. And online toxicity can also be very harmful. Its negative harms have been well recorded. For example, cyberbullying among school children has been connected to increased rates of anxiety and depression. Additionally, a study on Reddit found that people who had been the target of intergroup subreddit conflicts were less likely to contribute to their subreddits in the future. And unfortunately, toxicity also exists in open source communities. We know this because many open source practitioners have reported on their experiences with toxicity within the open source communities they engage with and the negative impacts it has had. Additionally, during the research part for this project, we came across tweet after tweet after tweet after tweet after tweet from open source developers who were expressing their frustration with their experiences with open source toxicity. And because of its prevalence and widespread negative impacts, toxicity has been studied thoroughly on various popular online platforms like Facebook, Wikipedia, Twitter, Reddit, and Stack Overflow. So the question might become, then, well, why do we need to study it again in the context of open source? And there are actually a few reasons for that. The first is, from research of toxicity on various platforms, we know that it tends to manifest differently on various platforms, and that there can be forms of toxicity that are platform specific and based on the way that people either use the platform or the actual characteristics of the platform itself. For example, RIP trolling is the trolling of memorial pages that are commonly posted on Facebook. It's a prevalent issue on the platform. There are multiple papers, research on it, blog posts, all kinds of stuff on how to deal with this RIP trolling on Facebook. But RIP trolling is not a significant or particularly prevalent form of toxicity on another platform like Twitter, for example. So from detection and intervention work, we know that different methods of identifying and dealing with toxicity are effective on different forms of toxicity. And we also know that depending on the type of toxicity a platform experiences, they tend to have success with using different strategies. And so because each platform experiences toxicity in a different way, they require different strategies for dealing with the toxicity. For example, Reddit was having a serious issue with hate speech. And so the solution they came up with was to delete a small number of subreddits that were responsible for a large majority of the hate speech occurring. And this ended up being successful in the long term, with over 80% of toxic users not returning or moving to another subreddit. Whereas you can imagine another situation where just deleting all of the toxic users on a different platform might not be effective, where they might just jump right back on. So we know open source toxicity exists because of reports from practitioners and other previous research projects, but there has not been much research done to actually understand open source toxicity and its characteristics. So in this project, we aim to address this gap in our understanding by looking at the qualities and characteristics of open source toxicity so that in the future we can build and utilize more effective identification and intervention strategies for dealing with toxicity in open source communities. Okay, now that we have introduced the motivation for this project and we're all emotionally invested in it, let's talk about some of the research methods. But first, before we jump into those, let's engage in an ethical discussion about some of the considerations we had when designing this research project. While some developers openly discuss their experiences with toxicity and its negative impacts, those discussions tend to be generic, abstracting from concrete instances. In previous research, we tried contacting developers who spoke publicly about toxicity, but for the large part, they either preferred not to discuss it or had already deleted the instances. Since toxic comments are usually unpleasant interactions, we intentionally discarded research designs that relied on interviewing or surveying developers, especially those who had not already spoken out about their experiences with toxicity. In line with the Belmont Report's ethical principle of benefice for human subject research, we considered the potential risks too high for an initial study. Instead, we decided to work entirely with public artifacts that did not require the contact of participants. So to address our research question, we knew we wanted to look at a bunch of toxic comments and then study their characteristics. But because there hasn't been previous research studying open source toxicity at this scope, there's not a pre-existing data set of toxic open source issues we could use. Therefore, to address our research questions, we had to follow two steps. First, collecting a sample of toxic open source issues and then analyzing them. So let's go ahead and get started with collecting our sample. Now, the first problem we faced when attempting to collect a sample of toxic open source comments is that there isn't yet a highly accurate and unbiased detector for toxicity of any form. Each detector picks up on different signals and is therefore biased in different ways. This was a non-trivial problem that we had to address when designing our research methodology, because the problem is, how can we identify open source toxicity if we don't know what it looks like yet? Additionally, since toxicity in open source is thankfully relatively rare, in prior work our group estimated about 6 per 1,000 issues are toxic. Analyzing a random sample of GitHub issues to find a significant or a sufficient number of toxic ones was also not a feasible random strategy. So without being able to use a specific toxicity detector and without being able to rely on random sampling, what do? We use 5 different strategies. I'm going to go through them really quick. These are the different ways that we identified potentially toxic issues. First, the language-based detector we used, which was built by our group in a previous paper. It's based on 2 pre-existing off-the-shelf models for toxicity and politeness. We first deployed this toxicity detector to identify original toxic issues, as seen in this example, where it just says shitty package with no context. And then we use the same detector to identify toxic issue comments. Issue comments are the responses to the original issues. In this example post, the issue comment is, "What's up with the hate? Why even bother posting this?" It's not a toxic issue comment. This is a toxic issue because the original issue was toxic. Then we identified issue threads that had mentions of codes of conduct. We also identified issue threads that had been locked as too heated. And finally, issue threads that had been deleted. More on how we had collected these in the paper. Now, if you recall, I mentioned that each of these detectors picks up on different signals. And we chose these 5 detection methods because the signals that they pick up on complement each other. For example, the toxicity detector is good at detecting toxicity that has obvious curse words and direct aggression, whereas identifying issues where they've been locked as too heated or mention the codes of conduct might give us an opportunity, and did give us an opportunity, to identify issue threads where the person was responding to a case of toxicity that was not in and of itself able to be identified by the pre-existing models. However, despite the fact that we carefully designed our detection strategy, as you might imagine, for example, not all deleted issues are toxic. So what we did was, once we had our potentially toxic issues that we automatically identified, we manually labeled a random sample of them that we identified again with our 5 strategies to create a sample of confirmed toxic issues. To assure the reliability of our labels, we had multiple authors independently label the issues. Inter-rater reliability, as measured by Cohen's unweighted kappa coefficient, was 0.82 for 149 comments with 2 independent labels, and Fleiss's kappa coefficient was 0.72 for 43 comments with 3 independent labels, which is typically interpreted as near perfect agreement. And what this tells us is that there was strong agreement between the researchers when issues were actually toxic or not. And additionally, the higher inter-rater reliability also indicates that having researchers label these comments rather than relying on original authors or affected users is or seems to be okay. Now, once we had our sample of confirmed toxic issues, we randomly selected 20 from each detection method, yielding a diverse random sample of 100 confirmed toxic open source issues. Now, it's important to note that while our sample was diverse, it was not necessarily representative of all open source toxicity, and there is more discussion on that in the threats to validity section of our paper. One thing to note, though, is that all 5 of our identification methods had very high false positive rates. For example, we can see here that we had to label over 400 toxic issues that were identified by our toxicity model, and only 82 of those were actually confirmed toxic, giving us a false positive rate of about 0.83. This tells us that although we invested a lot of work into building this toxicity detector, it still performed very badly, which in and of itself underscores the need to learn more about open source toxicity so we can better identify it in the future. Alrighty, now that we've gone through that, let's talk about our qualitative analysis. Are you excited? She's excited. So we used thematic analysis. More specifically, we used an iterative thematic analysis process where we were constantly moving back and forth between the stages of engaging with the data, coding, memoing, searching for themes, and refining our codes and frameworks, as recommended during qualitative analysis. In addition, we performed card sorting on the issue comments to gain a more in-depth understanding of the nature of toxicity in open source, since that was a key question of ours. This picture here that you see is of our pile for comments that were arrogant in nature. We chose to use qualitative analysis to understand and explore toxic open source comments because we wanted to approach them with an open mind and also look at many different dimensions of toxicity. Now you might be wondering, what are these dimensions of toxicity? These are those dimensions. We have dimensions like the nature of the toxicity, the trigger of the toxicity, who the author was of the toxicity. This mind map shows all the dimensions we identified. And through our qualitative analysis, we found these various dimensions of toxicity that helped encapsulate and characterize the toxicity we observed. For the sake of time, in the next section, we will only be discussing the findings related to a small number of these dimensions. However, the discussions of the findings for all of these dimensions and some of their really interesting interactions can be found in the paper. So if you're interested in learning more about these findings or what these dimensions even mean or their subcategories, I highly recommend that you check them out. So as we promised, let's move away from the methods into some findings. First things first. Open source toxicity is built different, as the kids would say. The nature of toxicity in open source discussions is different than that on other platforms. There are lots of insulting, entitled, and arrogant comments predominantly. As an example, this is an issue that was opened in an open source operating system platform with over 600 stars. This user was unhappy about the latest update and the removal of the minimize button in said update. Here are a few quotes from their issue. The problem is your team forcing us to use the operating system the way you want us to use it, although it makes it many times harder to use it your way than what would be convenient for us. Or, don't you really see how ridiculous is what's written in the blog post why there is no minimize button? Or, so maybe it's time to stop trying to be Apple or Windows and forcing people to use something the way you want it and give a simple solution to make it the way people want it. It's not a major change or something, just a simple solution. These quotes help encapsulate the entitled, demanding, and often insulting nature of the toxic comments frequently found in the open source communities we observed. Next, experienced developers are not necessarily non-toxic developers. If you recall from the mind map, one of the dimensions we analyzed was who was the author of the toxicity. The 4 major categories of authors I found were, first, experienced developers who had lots of previous experience in open source, but not in the particular project where they wrote the toxicity. Second, new accounts that had no more than 3 previous activities on GitHub in general. 3, project members, people who were contributors, members, or owners of the project they wrote the toxicity in. And finally, 4, repeat issuers. This was an interesting category. These are people who pretty much just wrote issues on GitHub. They often had a whole lot of them, but they didn't actually have any other activity on those accounts. And now, Despite the horror stories from the Linux community, we didn't expect project members to be frequent perpetrators of toxicity in their own communities. However, what we found was that toxicity was not only done by people external to open source projects or people with little experience. Project members were also frequent authors of toxic comments, which we found surprising. In this example, a user of a project found a bug. They wrote a solution for it and they created this issue. We did not categorize their original issue as toxic. Then a project contributor responded with a toxic comment saying, "You are all probably not using the latest version of the database. This is not my problem." They go on to say, "Expect a ban if you absolute idiots continue to spam me with Me Toos from this other issue that was related to it." Now, this example is highlighting the fact that toxicity was not only done by people external to open source projects. Project members were also frequent authors of toxic comments. However, it is interesting to note that most cases, they were responding to another comment that appeared to cause frustration for them. However, the comment that they were responding to was not always actually toxic, as in this example. Okay, now that we've gone over some results, what does it all mean? What do we do with it? Let's go over some implications. First, there is space, and some might say plenty of it, for open source specific detectors. Because off-the-shelf language-based detectors of toxicity trained on data from other platforms can now be relatively confidently expected to not generalize well on GitHub. For example, this user wrote a comment on a different issue thread. They became impatient after not receiving a response in 5 days, so they created an entire new issue, this one, referring back to their comment on the previous issue thread. And this blatantly passive-aggressive issue was called out by a project member and closed. Despite the fact that we and this project member established this as a toxic issue, if we were to run this, or if someone were to hypothetically run this through an existing toxicity detector, it would hypothetically not be identified as something with a high probability of being toxic. And this is because the milder language in these sorts of comments makes them more difficult to detect by looking for bad words or obviously aggressive language. Entitlement and arrogance are often not toxic through the use of strong language, but through the message they are conveying and the context they are conveying it in. This distinction may therefore require models that are trained specifically on a corpus of toxic open source discussions. Next, during our qualitative analysis, one thing we noticed was that there were clear harms coming from the toxic comments people were having to deal with. For example, contributors would often go into genuine, detailed conversations trying to solve a problem brought up in a toxic issue, or they would express clear frustration, disappointment, and confusion about the toxic issue itself. However, because the harms of toxicity were outside the scope of this project, we did not rigorously collect a lot of evidence about them. And although open source toxicity looks different than toxicity on other platforms, it is important to note that it is still stressful and can cause serious negative impacts to developers and members of the community, as we informally observed during our analysis. The frustration and other negative feelings we observed align with the many reports from practitioners in blog posts, talks, and even tweet after tweet after tweet after tweet after tweet. So, future work should investigate the harms of and impacts of open source toxicity more thoroughly. Finally, let's wrap it up with some summarization. In summary, online toxicity is harmful and pervasive across the internet, including in open source communities. Online toxicity manifests differently on various platforms, and different detection and intervention methods are effective for various forms of toxicity. While we know that open source toxicity exists, we do not have a sound understanding of its nature and characteristics, which we need in order to be able to help employ and develop more effective intervention and identification strategies for dealing with toxicity in open source communities. We address this by first collecting a diverse sample of toxic open source issues and then qualitatively analyzing them. We found that open source toxicity manifests differently than on other platforms. It tends to be centered more around entitlement, arrogance, and insults. Since the nature of open source toxicity is unique, future work should explore building open source specific toxicity detectors. Additionally, we learned that project members are also frequent perpetrators of toxicity. Finally, although we observed that there were direct harms of toxicity, we did not study them rigorously and in depth, and future work should do so. Thank you so much for your time and attention. Please feel free to reach out to us for information about the data set of toxic issues or any other questions. Have a good one. Bye. Say bye.